Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about quantum mechanics in molecular modeling. So let us start learning of parameters. What is parameters? Computer aided drug design, introduction to molecular modeling, types of molecular modeling, quantum mechanics, ab initio method, and semi-empirical methods, and application, and then references. So, computer aided drug design. Computer aided drug design CAD, CADD, represent computational methods and resources that are used to facilitate the design and the discovery of new therapeutic solutions. You know, my friend, drug design with the help of computers may be used at any of the following stages of drug discovery: hit identification using virtual screening or QSR. So, objective of CAD to change from random screening against disease assay and natural product synthetic chemicals. So, friend, objective of CAD to change from random screening against disease assay and natural product synthetic chemicals. What change? Change to rational drug design in testing, speed up screening process, efficient screening, de novo design, and integration of testing into design process. So look at here. This is your molecules, very small molecule. So there are different process like virtual screening, compound design, energy calculations, SAR analysis, ADME model, and drug target interaction. So keep these six things when we are talking about this molecule for the drug design. So molecular modeling is defined as theoretical methods and computational technique used to mimic the behavior of molecules and molecular system. Molecular modeling helps the scientist to visualize molecule to discover new compound for the drug. The common feature of molecular modeling technique is the atomistic level description of the molecular system and the goal to develop a sufficient accurate model of the system so that physical experiment is not necessary. So why medicinal chemists use models? What is the need? To help with analysis and interpretation of experimental data, to uncover new laws and formulate new theories, to help solve new problems and hint solution before doing experiments, to help in design new experiments, to predict properties and quantities that is difficult or even impossible to observe experimentally. So introduction to molecular modeling. You know, molecular modeling is anything that requires the use of a computer to paint, describe, or evaluate any aspect of the properties of a structure of a molecule. So method used in the molecular modeling arena regards automatic structure generation analysis of three-dimensional databases, construction of protein models by techniques based on sequence homology, diversity analysis, docking of ligands, or continuum model. So today molecular modeling is regarded as a field concerned with the use of all sort of different strategies to model modes and to deduce the informations of a system at atomic level. It is possible to conclude that computational chemistry is the nucleus of molecular modeling because it includes all methodologies used in the computational chemistry like computation of the energy of a molecular system, energy minimization, Monte Carlo method, or molecular dynamics. So, molecular modeling studies, the direct drug design. In this approach, the three-dimensional feature of the known receptor site are determined from X-ray crystallography to design lead molecules. Here, receptor site geometry is known. The problem is to find molecules that is satisfied some geometry constraints is also good chemical match. After finding good candidates according to these criteria, a docking step with energy minimization can be used to predict the binding strength. So indirect drug design, indirect drug design approach involve comparative analysis of a structure feature of known active and inactive molecules that are complementary with the hypothetical receptor site. So what is the role of quantum mechanics? How quantum mechanics is related to molecular modeling? So quantum mechanics provide information about both nuclear position and distribution based on a study of arrangement and interaction of electrons in nuclei of a molecular system. It does not require the use of parameters similar to those used in the molecular mechanics. So, it is based on the wave properties of electrons in all material particles. So, the mathematics of wave motions apply to electrons, atoms, and molecular structure. So, quantum mechanics based on the first principle, it is approach nuclei are arranged in the space and the corresponding electrons are spread all over the system in a continuous electronic density and computed by solving the Schrodinger equation. So, you know, the quantum mechanics is based on Schrodinger equation is psi is equal to E psi, which is equal to U plus K psi. You know the E energy of the system related to one in which all atomic particles are separated to infinite distance. H Hamiltonian for the system, it is an operator, a mathematical construct that operate on the molecular orbital and psi to determine the energy. So U potential energy, K kinetic energy, and psi wave function describe the electron distribution around the molecules. So quantum mechanics, biomolecules, this process can be done within the Born-Oppenheimer approximation. And for the most of the purpose, the Hartree-Fock self-consistent field is the appropriate procedure to compute the electronic density and the energy of the system. So types of quantum mechanics, it is in two parts, ab initio method and semi-empirical method. And ab initio method have two parts, Hartree-Fock approximation and density DFT, density function theory. So Hartree-Fock approximation, the central field approximation means Coulombic electron-electron repulsion is taken into account. The energies are calculated in a unit called Hartree. One Hartree is equal to 27.2116 electron volt. The advantages of this method is that it breaks the many electron Schrodinger equation into many simpler one electron equation. So Hartree's method was to write a plausible approximate polyelectronic wave function for an atom as a product of one electron's wave function. So advantage of Hartree-Fock approximation does not depends on the experimental data. A small system require high accuracy. What is the disadvantage? Every system have disadvantage, computationally expensive and time consuming. Now, density function theory. Density function theory is based not on the wave function, but rather on the electron probability density function or electron density function. So commonly called simply the electron density or charge density. And this theory used a statistical model to approximate the distribution of electron in an atom. So it is based on the sum of the exchange and correlation energy of a uniform electron gas can be calculated exactly knowing only its density. So does not depends on the approximate data. There are difficulty in using density function theory. So advantage of the density function theory is like it is also like the Hartree-Fock, but a small system and a system require high accuracy. What is the disadvantage? There are difficulties in using density function theory to properly describe intermolecular interaction, especially van der Waals force, dispersion, charge transfer excitation, transition state, global potential energy surface, and some other strongly correlated system. So, semi-empirical methods. Semi-empirical quantum chemistry method is based on the Hartree-Fock formalism, but make many approximation and obtain some parameter from empirical experimental data. They are very important in computational chemistry for treating large molecules where the full Hartree-Fock method without the approximation is too expensive. So the use of empirical parameter appears to allow some inclusions of the electron correlation effects into the method. So, what is the advantage of semi-empirical methods? Semi-empirical calculations are very fast compared to ab initio and even to density function theory. Medium size systems, hundreds of atoms. And what is the disadvantage? Disadvantage of every system is little bit there. Does uh, depends on the experimental data, small system, and low accuracy. So, my friend, this is the reference practical application of computer-aided design by Paul S. Carifson, Marcel Decker, Chapter 3 Molecular Modeling Technique by Swami Ramanand, 3rd Mahabharata University, and Basic Model Molecular Modeling Docking Slide Share. So, my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.